In this next collection of problems from 105 to 108, we are again using the different properties of derivatives, including the quotient rule and the product rule, in order to evaluate derivatives. Here we're not given the exact functions, but we're given the values of functions g and h when x is equal to 2, and also the derivatives of g and h when x is equal to 2. So for problem 105, we have f of x is equal to 2 gx plus h of x. And so the derivative of that, the derivative of a constant times a function, is equal to the constant times the derivative of the function. So that would just be 2 g prime of x. And the derivative of h of x is just h prime of x. So then to find f prime of 2, we simply need 2 times g prime of 2 plus h prime of 2. Since g prime of 2 is negative 2 and h prime of 2 is 4, we get negative 4 plus 4 equals 0. Then for problem 106, f of x is 4 minus h of x. And so the derivative f prime of x would be simply negative h prime of x. And f prime of 2 would be negative h prime of 2. Since h prime of 2 is 4 above, this answer would just be negative 4. For problem 107, we have f of x is the quotient of g of x and h of x. So the derivative, f prime of x, will be low d high, or h of x g prime of x, minus high d low, or g of x h prime of x, over low squared. And so f prime of 2 would be h of 2 g prime of 2 minus g of 2 h prime of 2, all divided by h of 2 quantity squared. Since h of 2 is negative 1, g prime of 2 is negative 2, g of 2 is 3, h prime of 2 is 4, and h of 2 is negative 1, quantity squared is positive 1. And so we have negative 1 times negative 2, which is 2, minus 12, which is negative 10. And that would be the final answer for 107. In 108, we have a product. F of x is g of x times h of x, so the derivative f prime of x would be 1 d2, so g of x h prime of x, plus 2 d1 h of x g prime of x. And so f prime of 2 would just be g of 2 h prime of 2, then h of 2 g prime of 2. G of 2 is 3, h prime of 2 is 4, h of 2 is negative 1, and g prime of 2 is negative 2. So we end up with 12 plus 2, or 14. And that does it for this set of problems. So here, once again, what we're doing is we are using some given values of a function and of a function or a few functions and some of their derivative values to actually evaluate derivatives of different expressions involving those functions and evaluating them at certain values of x.